2.1 lines and their graphs. So first, let's start off with properly labeling a Cartesian plane. We need an x-axis, a y-axis. We need arrows. Then any point on a graph is known as an ordered pair, which is an x value comma y value. 0, 0 is known as the origin. The quadrants on your graph do not have to be labeled, so this is just for communication purposes. But the upper right is quadrant 1, where x and y are both positive. The upper left is quadrant 2, where x is positive, x is negative, y is positive. The lower left is quadrant 3, both negative. The lower right is quadrant 4, x is positive, y is negative. So first we want to learn rate of change. This is delta y, which just means the difference in two y values, or simply change in y. This is delta x, the change in x. So the rate of change is defined as delta y over delta x. So commonly we use the letter m and refer to this as slope. So if m is greater than 0, that means we have a positive rate of change, which tells us as x increases, y increases. So as we move this direction, y to the right, y moves up. And that can occur if delta y and delta x are both positive, or delta y and delta x are both negative. So negative slope would mean delta y and delta x have opposite signs, and as x increases, y decreases. A horizontal line has 0 slope. A vertical line has undefined slope, since delta x would be 0, so we just say m is undefined. Parallel lines have equal slopes. Perpendicular lines have negative reciprocal slopes. So what that means is if we have 3 over 4 as our slope, a perpendicular slope would be negative 4 over 3. The forms of a line: slope-intercept form, point-slope form, and standard form. So in this example, we're going to find the equation of the line given m equals 5, and we have the point 0.8. So the most efficient form of a line to use in this one would be y equals mx plus b, slope-intercept form. So we plug in 5 for m and 8 for b. And then we want to be able to properly graph. So plot 0.8. Now to find any other point, you pick an x value in the domain. So non-vertical lines have domain all real numbers. So I just chose x equals 1, plug that in, and get 13 for the y. Plot that point, label, draw the line through your 2 points. Okay, same set of instructions. We're going to find the equation, but this time we're given a slope and a point that is not the y-intercept. So we need to use point-slope form and substitute in 5 for m, 1 for x1, 3 for y1. And let's simplify down to slope-intercept form. And let's just make sure that we're able to graph and write in standard form if necessary. And then we're going to refer to this example as the base case, because these subsequent cases all revert back to this procedure. So now we're going to find the equation of a line given 2 points. So since we are not given the slope, we need to calculate the slope. So calculate rate of change, and we get -2. And then now that we have the slope and a point, this becomes the same as the base case. So we're going to apply point-slope form, simplify, and then in this example, I went ahead and wrote the line in standard form. Now we're going to find the equation of the line parallel to a given line. So we're given 6x minus 3y equals 8, and the line that we are looking for must pass through -2, -7. So the first thing that we need to do is find the slope from the line that is given. Commonly, we just solve for y and put that in slope-intercept form and site identify the slope. Or if you're a little bit more familiar with standard form in this situation, the slope is -a over b. So we've got a slope of 2. Now that we've got a slope of 2, we just need to know that parallel lines have equal slopes. So the slope of the line that we are finding is also 2. And now that we've got that, this reverts back to the base case. So apply point slope form, sub in the slope, sub in y1, sub in x1, and simplify, and I just left this in slope intercept form. Okay, on this one we're going to find the equation, the line that is perpendicular to y equals -1 over 4x plus 7, and it passes through 1 over 9. So the only difference between this example and the previous example is that we need a perpendicular slope. So the slope of the given line is -1 over 4. So the negative reciprocal is the perpendicular slope. So flip the fraction, multiply by -1. So the slope of the line that we are finding is 4. Now we revert back to the base case. And I'm just being specific here with my m perpendicular because the slope of the line that we are looking for has the perpendicular slope. So sub in for m perpendicular, x1, y1, and simplify. Again, we could put that in standard form. We could also be asked to graph that line.